So folks, in this pre-work here, we want to review the topic of factoring, and I think that it'd be helpful to review some vocabulary. So below here, I have two mathematical expressions, and each one of these expressions is constructed a little bit differently, and I want to highlight those differences. So let's first get some vocabulary out of the way. We call each one of these a mathematical expression, and again, we're going to call these expressions not equations. Notice that there is no equal sign. So let's go ahead and label some of the parts of these. This first expression here is, we're going to say that this looks different than this. We're going to say that this is a sum of three terms for this expression here. So we're going to call this whole thing a sum, and we're going to label each part of the sum. Now here I'm not going to worry about the difference between sum and difference. So even though that's a subtraction sign, I'm still going to call that a sum. So here we have these three terms. So what have we said above? We said the above expression, the first expression, is a sum of three terms. Now let's look at this second expression. The overall operation between these two sub-expressions is it's an implied multiplication. That is, I didn't put a multiplication dot there, but it's implied that I'm multiplying these two expressions together. So this second expression is a product of two factors. So again, we would label this whole thing because the big picture is that we've got this expression here and this expression here, and what am I doing with them? I'm multiplying together. So this whole thing we think of as a product. Now, what are the parts of a product that we multiply together? Well, we call this first expression, we call it one of the factors, the first factor, and we call this second one a factor. So let's go ahead and label the various parts of these expressions above. That's what we just did, as either terms or factors. So again, just to highlight this, here we have this term, this term, this term. We have these three terms that comprise this sum, and here we have this expression and this expression. These are both factors, and the whole expression together is called a product. Okay, so notice that this isn't quite as clean. I mean, I wish I could break math up just that simply, but it's not quite as clean as we like. If we were to go look at one of those factors, this factor right here was the factor 3x minus 2, but notice that it itself is a sum of two terms. So it's not quite as clean as we'd like it to be. That's not something we're going to really, I mean, we could spend hours sort of dissecting this, and let's not. But the big picture of this first expression here is that it's a sum of three terms, and the big picture of this second expression here is that it's a product of two factors. So let's just catch up with our notes. For the expression on the right, this expression right here, even though we're calling it a product of two factors, each factor, this is one of the factors, this is one of the factors, each of those factors is comprised of two terms. So let's go ahead and say that we're going to call this first expression right here, besides calling it a sum, we could specifically call it a trinomial. And the reason why we would call it as trinomial is because it's a sum of three terms there. And we could specifically call this piece of this factor right here a binomial. Okay. So this first factor is comprised of two terms, and 2 we use the prefix bi, versus 3 we use the prefix tri. Okay. We can call the second expression a product of binomials, since each factor of the product is a binomial, meaning it is a sum comprised of two terms. Okay. So folks, I know this feels a little bit pedantic to go through and label all these parts, but I'm going to be using this vocabulary as we talk about factoring, so it's important that we're all on the same page. Okay, let's go ahead and look at that's one of those two expressions. Let's look at the second expression. Remember what we said. So we called this a product. There's an implied multiplication there, a product of two factors. What do we notice? Well, I'm asking you to go ahead and expand this out. So we've got 3x minus 2 times x plus 6. And if I go to expand this out, I'm going to do a process called FOILing, if you like. There's lots of ways to think about it. But remember, the general rule for multiplying a polynomial, specifically a binomial, by another polynomial, specifically a binomial, is to simply multiply each term in the first to each term in the second. So, well, you may have an acronym FOIL, or you may have other ways of doing this, bookkeeping methods for expanding these. All of them are just short or kind of helpers for saying we're going to take this first term in the binomial and multiply it to each of these two terms. And then we're going to take this second term in the binomial and multiply it to each of these two terms in the second. So let's go ahead and do so. When we multiply this out, when we multiply this out, we get 3x squared plus 18x minus 2x minus 12. And if we clean things up, we end up with 3x squared plus 16x minus 12. So what I wanted us to observe here, and it's a little hard because I'm zoomed in, is that these two expressions are actually equal expressions, meaning if I were to expand this this product right here, I end up with this sum over here. Okay. Likewise, what we eventually want to do is take this sum and rewrite it as a product. So this way, let me go ahead and just show you this. Simplifying this way, let's see here, we'll pick a color we haven't used yet. Simplifying this way is a product called expanding. And if we go from a product to a sum, we're going to call that expanding. And it's just using your distributive property. Just if you like, you could say FOILing it out or doing the process that we just described. And if we come back the other way, if I start with a sum of terms and I want to write it as a product, we're going to call this the process of factoring. Okay, let me make those both ing words. So this going from a product to a sum is expanding. Going from a sum to a product is called factoring. And that's the more difficult of the two tasks, and that's the one we want to highlight over the next few days. So factoring is a tool that allows us to rewrite a sum of terms as a product of factors. That's our goal. Our goal is to take an expression that looks like this. So notice I've stripped away all of the mathematics from this, and you just see that I've got a sum of, in this case, 3 terms, and my goal is to rewrite it as a product of 2 factors. Okay? So the expression, this is the expression we were looking at above, 3x squared plus 16x minus 12, is said to be in expanded form. The expression can be written as 3x minus 2 times x plus 6. That's what we just saw here. And that's said to be in factored form. I'm not going to get too into the weeds about exactly what we mean by factoring. I'll just verbally say that we have written this as a product of 2 prime factors, and so that's what makes it in factored form. In general, factoring can be thought of as undoing the distributive property, or using the distributive property backwards. So there are many reasons why we want to learn how to factor. It's useful for a lot of various tools. Let me just show you one of them. Okay? So below we actually have an equation this time. Notice that we do have an equals sign, so this is an equation, and we want to solve this equation. So we're simply often just rewriting expressions or simplifying expressions or manipulating expressions. Equations are something we want to solve. We want to find the variables that make this statement true. So here I have something that's called a quadratic equation. You've hopefully seen it before. And we want to go ahead and solve this quadratic equation. Well, you may know some other methods for doing so, like maybe using the quadratic formula or the process of completing the square. Arguably, the simplest way to solve this particular quadratic equation is through factoring. So notice that the original equation, I've got all of the terms collected over to one side and we're set equal to 0. That's important. And this is a sum of 3 terms. It's a trinomial. And we just saw that it factors this way, that it factors to be 3x minus 2 times x plus 6. So where in this problem we're looking for, hey, what numbers can we plug in for x to make this statement true? So if I simplify everything on the left-hand side, that it equals 0. Okay. Now I've kind of pass that problem along to a new problem. I'm looking for the numbers x that I could plug in so that this expression, when you multiply these two factors together, gives you 0. Now, why is this beneficial? It kind of looks like we traded one problem for a different problem. The reason why is because in math we have something called the zero product property. What does the zero product property say? Well, it says if the product of two numbers, now this is a product because we've got that implied multiplication there, actually explicitly stated that multiplication there. If the product of two factors is 0, then what do you know? I want you to think about this just for a moment here. I've got two numbers. I'm multiplying them together and the result is 0. What do you know? What we know is that either A is 0 or B is 0. And let me just say, in math, whenever we use the word or, we mean or both. So if two numbers being multiplied together give you 0, it can't be 3 and 7. It can't be 5 and 4. It has to be 0 times some number or some number times 0. That's my zero product property. Okay? So that maybe seems like kind of an obvious fact that maybe you say, oh, I didn't even need to think about that. But we're going to use that zero product property right here to go ahead and finish solving this equation. So notice up above here, I have a sum of terms set equal to 0. I don't have any property for that. For example, I can think of lots of sums of three numbers that when I add them together, I get 0, such as 3 and 2 and -5. Those add together to be 0. There's lots of answers to that. But in this next line, I have a product of two factors equaling 0. And by the zero product property, these both can't be just any number we want. One of them must be 0. So either 3x minus 2 equals 0 or x plus 6 equals 0. And you see what we've traded off. Okay? We started off with a quadratic equation, and we couldn't easily identify the solutions to that quadratic equation. But in this case, this quadratic equation factored nicely in the reals, so we put it into factored form, and then I used this zero product property here to set each of the two factors equal to 0. And the trade-off is we started with a quadratic, and now we've got two linear equations. Linear equations are our bread and butter in algebra. Those are the easiest ones to solve. We know all about them. There is no difficulty in solving these. So we took this more challenging problem, solving a quadratic equation, and rewrote it through the zero product property as two linear equations. Now, what allowed us to do that? We couldn't do it right off the bat here because this was written as a sum of terms. But we could use the zero product property once we thought of it as a product of two factors. That enabled us to use see it in the word here, the zero product property. So now we can solve each of these. We get 3x minus 2 is equal to 0, or 3x is equal to 2, or x is equal to 3/2. That's one of the numbers, and you can check, you can verify. If you take 3/2, plug it back into this quadratic equation, you will get 0, or x is equal to -6. So that gives us the two solutions, 3/2 and -6, and you can verify that each of those solves this quadratic equation. Okay, so folks, that's why factoring is important, and hopefully this reviewed the vocabulary that we're going to need as we practice our factoring. But in the next video, we're going to look at a very specific technique called factoring out the greatest common factor. So I'll join you in that video. See you there.